Merry Christmas. Welcome back. We are going to finish up 3.1 here. I wish I was in school to teach you guys this because this is the best section of the entire year is graphing polynomial functions. We usually have a fun activity to do with this, but nevertheless, here we are. Today we're going to learn about a multiplicity of a zero, if a zero balances, wiggles, or crosses. And then we're going to learn how to graph it and then also how to write an equation of a polynomial function. So first I want to begin by reviewing each of our parent functions that we have. Okay, so first we're going to start off with just y equals x squared, just this very common function here. And what happens, it's a parabola, right? It comes down and it touches at 0 and it goes back up again. And so notice that we have, it touches there at 0. Notice that we have both of our ends going up. And so it kind of should start looking familiar that we have an even function here. Both of our ends go in the same direction, right? For y equals negative x squared, notice that my coefficient is negative, right? The number in front of my x is negative and my power is even. And so this graph actually goes upside down. It still comes up and touches my 0 and goes back down again. My arrows are still both going in the same direction, so it's an even function. But this time my right-hand side is going down, and that's where that negative comes in, if you remember that from the first part of 3.1 on our end behavior. If it's a positive leading coefficient, my right side goes up. If it's an even function, both ends do the same thing, okay? Now what we're going to do is we're going to look and see what it looks like with just a line, okay? So just y equals x. If we just have a regular line, y equals x, it just goes up through here like this. It's a positive leading coefficient right here, right? A positive slope. And so right here is positive, so my right side goes up. It's an exponent of 1, so it just passes through 0 right here, okay, right here. If we look at y equals negative x, that graph actually is a graph that just goes down through the origin like so, okay? We still have, negative, it should be negative x, sorry about that, negative x. And this negative tells us that this right-hand side goes down. Our power of 1 right here is an odd function, so that means it's going to be opposite on the other side. Just like over here, positive goes up, the odd tells us it's going to do opposite on the other side. So my end behavior, they're doing opposite things, right? They're going opposite directions, right? Well, we're going to take a look at a function that you guys are not particularly familiar with. It's called a cubic function, y equals x cubed. We may have touched on these a little bit, we may not have. The basic function of this is 0 cubed is 0. If we plug in 1 cubed, 1 would be 1, and then 2 cubed would be 8. If we plug in negative 1 cubed, it would be negative 1, and negative 2 cubed is negative 8. So this is my basic, it's called a cubic function. It kind of does a little swerve through the origin, if you call it, or just we call it a wiggle, actually, okay? And so notice that we have a positive leading coefficient, so my right end is going up. We have an odd function, so that means my other end is going to be doing the opposite thing, okay? And so that's what that basic function looks like as a cubic function. So you would think that then if we have y equals a negative x cubed, it's going to be doing just the opposite thing, so the graph is going to flip upside down. So it's going to do the same thing, it's just going to kind of wiggle through my origin, but go the opposite direction. My right-hand side is going to go down, and because it's an odd function, my left-hand side is going to do the opposite thing. Okay, so these three functions become very, very important in what we're going to do to graph our polynomials. Okay, so it's important to know the basic parent functions. These are kind of all of our functions we've learned so far. We've learned absolute value. We're not going to so much cover these absolute values in this function as we are just lines, straight up lines, y equals x, y equals negative x, and x equals squared, and y equals cubed. Okay, and then this one, whatever that is. Okay, all right. So first of all, we're going to talk about multiplicity. What does multiplicity mean? First of all, it refers to the multiplicity of a 0 refers to the number of times a 0 appears, how many times it happens. It's like, you know, when you factor, sometimes you have multiple factors. So in this case, don't worry about factoring this. We're not going to worry about that. But this ends up becoming this in a factored form, which would be x times x plus 2 times x plus 2, right? And then times x minus 1 times x minus 1 times x minus 1. And so this 0 of 1 occurs 3 times, and that appears right here. So that means that's a multiplicity of 3. So that 0 occurs 3 times. This 0, negative 2, occurs twice, okay? This one right here, this just has a multiplicity of 1, so that equals 0. So you can rewrite this x minus 0. You can write that as x minus 0. So that's how you know it's always a 0 at 0. It's kind of confused to say a 0 at 0. Okay, it crosses at 0. So that's a single 0. X plus 2 is a 0 of negative 2 with a multiplicity of 2. Okay, x minus 1 cubed leads to a 0 of 1 with a multiplicity of 3. So this concept of multiplicities becomes very, very, very important. Okay, because here's what happens. With the multiplicity of 1, if you zoom in on it, it kind of looks like a line. It just crosses through like the line would, x, y equals, like the y equals x line, right? Just looks kind of line passing through there. If you have a multiplicity of 3, it kind of looks like that little squiggly one, like the cubic function looks like. And I should say a 3 or a 5 or a 7, any odd function. A 0 with a multiplicity of 2 ends up looking like, if you hone in on it and zoom in on it, it looks like a parabola. Okay, and parabolas kind of come down and bounce off of the axis. Okay, and so this has a multiplicity of, and that's 2, 4, 6, or 8. Any even multiplicity looks like that. And we call these bounces, we call these wiggles, and we call those crosses. Okay, and so this is what we have. Okay, a bounce is a factor with an even exponent. Okay, the exponent has a multiplicity of that factor. So it could be 2, 4, 6, 8. What happens is, if it gets the higher the multiplicity, the flatter it gets. So if we have, say, y equals, x to the 8th, it would look something more like, it would come in and kind of get really flat like this. You can play around with that. This is what we used to do in class, is kind of play around and enter these all in our calculators and Desmos and say, what would it look like? Okay. Wiggle has an odd exponent greater than 1. So it has to be like 3, 5, 7. So it just doesn't include 1. Okay, so I might even put over here, x cannot be equal to, well, exponent cannot be equal to 1. Okay. The exponent has that multiplicity, that factor. And same thing, if I had y equals x to the 7th, it would just become a flatter wiggle. So if I have y equals x to the 7th, it would just have something like this, where it come through and just be flat as it wiggled through there. Make sure you know how to draw a wiggle. I have lots of people when they graph kind of do this sort of wiggle thing down here and try to, it just kind of wiggles, it just kind of draws through. So make sure you kind of practice drawing your wiggles, okay? All right, I'm gonna erase that little guy there too. And then a cross just has a factor and exponent of just 1. So anytime you have an exponent of 1, it's just a straight through, just like a line, okay? Just it passes through, we call it a cross. So bounce, wiggle, cross, become bounce, wiggle, cross, okay? So there's want to become very familiar with this. Cross is just like a line, a bounce is like a parabola, in an even number, and then wiggles are all of my other odds besides 1. Okay, so now let's go ahead and practice graphing a polynomial. All right, so the very first thing I like to look at is end behavior. So we look at our leading coefficient. Is my leading coefficient positive or negative? Okay, and actually the first thing I want to do is actually have this in factored form. Sometimes it's in factored form, sometimes it's not. Big ones I'm going to give to you in factored form. Little ones you're going to be able to factor on your own. So I'm going to go ahead and factor this guy. I'm going to factor out a GCF, which is x, and that will leave me with x squared minus 2x minus 15. And I'm going to factor this guy, factors of 15, and add up to negative 2. That's going to give me x times, and then this is going to factor 2, x minus 5 times x plus 3. Okay, my leading coefficient is still positive, so I know it's going to be going up on my right-hand side. Okay, so I kind of like to draw my arrows and get the map. We kind of put together a map. Okay, if it's negative, of course, it would be going down on the right-hand side. And then is it an even function or an odd function? Okay, so to find out what that is, we're going to look at my highest power in standard form, or I'm going to look at all my powers of my factors and add them together. 1 plus 1 plus 1 is 3, so it's a power of 3. You need to make sure you know how to do that in both ways. Okay, what is my function odd? We look at my highest power in standard form, or I add all my powers together of all my factors, and that's what my power of my function is. So that's a 3, power of 3. Because if I multiply them all out, that's what I get. Okay, so it's an odd function, so that means it's going to be doing the opposite thing on the other side. Okay, now we're going to look at our zeros. We have a 0 of 0 because this is the same thing as x minus 0, right? So it crosses through 0. Don't ever forget about that guy. That one always gets forgotten. Okay, we have a 0 at 5. 1, 2, 3, 4, 5. And we have a 0 at negative 3. 1, 2, 3. Okay, now it's important to figure out, what are they doing right there? Are they crossing? Are they bouncing? Or are they wiggling? Well, in this case, they have a multiplicity of, so we have a 0 at 0, and it has a multiplicity of 1. We have a 0 at 5, and it has a multiplicity of 1. And we have a 0 at -3 with a multiplicity of 1. So they all cross, right? The next thing we want to know first is our y-intercept. Now for y-intercept, we can plug in 0 for all of our x's and find out what we get. So if we plug in a 0 here, here, and here, we get 0. We can do the same thing in factored form. If we plug in 0 times 0 minus 5 times 0 plus 3, it ends up just being 0 times -5 times 3, which ends up being 0. So again, there's our y-intercept is 0, so we got that already. Okay. Anytime we have just a single x right here, our y-intercept will be 0. Okay. Now we just have to put it together. We know that we're going to cross here, we're going to cross here, and we're going to cross here. So we're just going to take this and go cross, turn around and cross. You're going to turn around about halfway and cross, and then we'll make sure put our arrows on here, and there we go. We just put the map all together. Okay. And that's how you graph a polynomial. Now, of course, this could go, we're just sketching these polynomials. This is not exact. If I see exact graphs, I know that you're cheating in Desmos. Don't cheat in Desmos, okay? So make sure you're just sketching these graphs out, okay? Because I will give you a quiz where you cannot cheat in Desmos. All right, so let's try this again. You might want to pause this and try this on your own and see how you do, okay? All right, so this is already in factored form. So let's look at our end behavior. We have a leading coefficient that's negative. That means on the right-hand side, it is going down, okay? Let's look at our total power. Is it an even function or an odd function? We have to add all these together. 2 plus 3 is 5 plus 1 is 6. So that is a power of 6, okay? So it's an even function. So my power is 6. Okay, so it's going to be doing the same thing on the other side, right? Next, let's find our zeros. I have a 0 at, I don't know what's happening there. We have a 0 at x equals 0. That's what this guy is. We have a 0 at x equals 2. And we have a 0 at x equals -1. Because I have a 0 at 0, that is going to be my y-intercept right there, right? And then x equals -1 and x equals 2. We just have to figure out, do they bounce, wiggle, or cross there? Okay, so this one here, this is a power of 2, so that's going to be a bounce. Okay, this is going to be a bouncer. So we'll come over here and put a bounce right here. Okay, at 2, that's an odd power, so that's going to be a wiggle. So I'm going to go ahead and put a wiggle, a W underneath here, and I'm going to go over here to my positive 2, and I'm going to put a wiggle above it, so I know it's going to wiggle. Okay, at -1, I have a power of, that's a 1, a power of 1, so I know that's just going to cross. So I'm going to come up here and put a cross above my -1. Now I just have to put them all together. We know our y-intercept is at 0, and now I'm just going to put it all together. So I start down here, right? Going this way. I'm going to go this way. Cross. I have to turn around pretty steep here. Turn around, go in here, and bounce. And then I'm going to have to give myself some room to wiggle. Excuse me, and wiggle. Okay? Excuse me. Woo! And that's how you put together a polynomial graph. All right? They don't have to be exactly perfect. Try to draw them as best you can. Make sure you have some graph paper. I don't want anything that's not on a graph paper. No regular paper. Okay? All right. So this is an interesting thing. Like, this is called a relative maximum. These points up here are a relative maximum. And it's a point where the graph reaches the highest point in its general region. So if I'm going to actually move in and zoom in right here, that is a maximum in that area right here. Okay. In this area right here, this is also a relative maximum because that's a maximum point in that general area. Okay. Down here, this is a relative minimum because in this zoom area, that is a minimum. So in every polynomial, we have a relative maximums and relative minimums depending on where we're at. Okay, how many we have. You can also look at tables and tell where the function is decreasing and where it's increasing. You can tell that the function is decreasing until right here where x is -2, and it turns around and starts to decrease in value. So it goes from 4.5 down to 2. And so right here about -2, it turns around, starts to go back down. Okay, and it turns around back right here and starts to increase in my function and then decrease again. We can also tell where our functions are positive and negative. Okay. All right, so now we're going to sketch some polynomial functions given intervals. Okay, So f of x is positive over the intervals from negative infinity to negative 4. So it's positive up to negative 4. 1, 2, 3, 4. That must be a 0 right there. Okay. And then again from negative 1 to positive 4. 1, 2, 3, 4. It's also going to be positive. So it's going to be, my graph is going to be up here in these two areas. Okay. It's negative on the intervals between negative 1 and negative, right here. It's going to be negative. And then also from 4 to infinity, so over here, my graph's going to be down below, right there, negative. The increasing and decreasing, I'm not so worried about because it's usually halfway between each of these guys, okay? Until we start to get into complicated graphs, which you're not going to get into until next year if you take pre-cal, but it's usually somewhere between the, halfway between these guys. So we're just going to put this together here, and we're just going to turn around about halfway. Okay, about halfway, turn around. Somewhere up here, about halfway, turn around. And if you're not quite sure where halfway is, that's what these guys are for. Okay, so it's increasing intervals to negative 2.672, 2. So right here at 2 is about when we turn around. So you might want to kind of gauge that general area. And that's how you graph a graph giving intervals. Okay. So here's one for you to try again. All right. So you can pause if you'd like to and come back and see how you do. So we have a positive f of x is positive on the intervals of negative 2 to negative 1. So right here and right here, we're positive right here. And then 1 to 2. So right here, 1 to 2, we're positive right here also. Okay. I'm actually going to go ahead and color code. So we're negative on the intervals between negative infinity to negative 2. So we're negative down here. Negative 1 to 1. And then 2 to infinity down here. Okay. And then we're increasing on all these intervals. But again, these are close enough together that I could probably decide where they're going to turn. So I'm going to go down here. I'm going to increase, turn around, come down, turn around, come up, come around, come down, and there we go. Okay. And there we go. And let's put together a graph that way, given the intervals. All right. Okay, so now we're going to write an equation given a graph. Okay, so this is what's going to be important for you to be able to do. And that's why it's important for you to be able to go both ways, because you can graph a function in Desmos, but you can't really go backwards. Okay, so first of all, we want to write our zeros. Okay, so what are all of our zeros? We have a 0 at x equals negative 3, at x equals negative 1, at x equals 0, and at x equals 2. Okay, we have zeros all those places. When we write an equation, we want to write all of our zeros. It's always x minus my 0, like this. So we write them in factored form. X minus my 0. X minus my 0, such as x minus 0, and then x minus my 0, 2. Okay. So this would all be x plus 3, and x plus 2, x, and x minus 2. So now I can kind of start to put some organization to it a little bit, okay? So it looks like we just cross here, we cross here, we cross here, we cross here. So these are all crosses, so we don't have any powers in these. I want to check the right-hand side, and I'm going up here, so I'm going to have a positive leading coefficient, okay? And I want to check and make sure that my y-intercept is 0, which it is, and that just means I have a single x there in the front, and I'll show you how to find that if it's not that. So I can put this all together now. So my f of x, or y, equals, and I'm always going to put that x in front. Okay, this guy always goes in front. And then I can put these in any order. I really don't care. X plus 3, x plus 2, times x minus 2. And that is your equation for your function in factored form. Now, at some point, we're going to be putting them in standard form, but that's not today. Okay? All right, let's try one more. You guys can go ahead and do this one. And then, we'll do this together, I guess. Okay? So my zeros are going to be at, this is, let's see, negative 2. So x is negative 2. Whoops, negative 2. Yeah, can't see that very good, can you? Try this again. X equals negative 2. At x equals 0. And at x equals 2. So if I write them in factored form, as factors, it would be x minus negative 2. X minus 0, and then x minus 2. Okay. This time I'm going down on the right-hand side, so I know I'm going to have a negative leading coefficient. So my f of x is going to be equal to a negative, okay? And I know I have a y-intercept here that's just 0. I just have a single 0 there. So that's going to be x times x plus 2 times x minus 2. And that's our equation of our function, okay? These bumps and stuff, there'll be some numbers in here like x equals, you know, I don't know, 15x and so forth. That's going to determine how steep those bumps are. But all we're doing is coming up with an estimate of our function, okay? And I want you to notice too, the fundamental theorem of algebra says basically, as number of zeros we have is usually equal to what our power is. So I should have a power of 3 when I'm done. If we have 3 zeros, we should have 3 factors, okay? Or 3 zeros, all right? Okay, let's try one more. Now this one does not have a y-intercept of 0. So I'm going to show you how to find that, okay? So let's get all of our zeros together. Okay, so we have x equals -1, x equals 2, and x equals 4. I'm going to write them as factors as x minus -1, x minus 2, and x minus 4. Now I want to find out what their multiplicities are. This one is a bounce, and so I'm just going to assign it, put a bounce, right? I'm just going to assign it just a power of 2. I'm not going to get really fancy and say, oh, that's going to be a 4 or a 6. I don't care, okay? This is a wiggle right here at 2, so that's going to be a power of 3. And this one just crosses through here, so this is, so I've got a wiggle and I cross. So this is going to be just a power of just 1, okay? We're dropping down here on the right-hand side, so we want to make sure we have a negative leading coefficient, okay? So we have this f of x equals, now, this is how you tell our y-intercept. First of all, let's just go ahead and write this out. So we have f of x equals a negative x plus 1 squared times x minus 2 cubed times x minus 4. If I plug in 0 for all these x's, what I will end up with is a -1 times, if 0 plus 1 would be 1 squared, right? 0 minus 2 would be -2 cubed. And 0 minus 4 will be just -4, okay? So this would be -1 times -8 times -4, okay? This will end up being a negative, and that's a positive 32. So -32. So this is what we end up with if we plug in 0 for x. But we need to have our y-intercept is -4. Okay, so we need to multiply. So all these are multiplied. We need to multiply this -32. So we need to take something times -32. It'll actually give us that -4 is what we want, right? Okay, so what are we going to multiply by? I'm going to actually put a, because that's what we actually are going to try to find. A times -32 equals -4. So I'm going to divide by -32. So a equals a positive 1/8. So that's what our number is up there, our a. Okay, so I'm going to put our f of x equals 1/8 times -1/8, sorry, -1/8 times x plus 1 squared times x minus 2 cubed times x minus 4. Okay. I think I needed to make that with this, not this -1 here to find that 32. Sorry about that. Okay, so there's our function. You can excuse me, you can test it out by taking 1 squared times -2 cubed times -4 divided by 8. That should give you a -4, right? Divided by -8 should give you a -4. Okay, and that'll give us our y-intercept and all of our zeros. Okay, so that is how you write an equation for a polynomial function. Most of the ones I'm going to give you are going to have zeros for x, like those guys, but you will see a couple of them like this guy here. Okay. Next up, we just have basic interpreting a graph, which is just looking at a polynomial and getting information from it. So Abby creates a function to model a situation which you don't even know what she's talking about. So she puts in baking soda and then takes how much time it's going to take to blow up a balloon with 5 quarter cups of vinegar. And she wants to know how long would it take to inflate the balloon with 5 quarter cups of vinegar. So we look over here. I'm trying to pull this up here. It's not working too good. I'll see if I can get it over here. Here we go. So with 5, we come up here at 5, boom, and it's about, we're close to, let's see if I can get right on 5 here. There we go, 6.26, right? We get 6.26 is how long it will take to inflate the balloon with 5 quarter cups of vinegar. So my vinegar is down here on the x-axis, and my blowing the balloon up is on the vertical one, okay? All right, so it just says right here, for data, Abby created a function to model a situation for X quarter of cups of vinegar. It takes this many seconds to inflate the balloon. Okay, so my time is on my vertical axis, and so that's what this is about. So we're not going to touch a whole lot on this interpreting. Just wanted to kind of introduce it to you, focus most on the graphing and interpreting and knowing what the zeros and multiplicities are, okay? Here is just kind of a concept summary of 3.1, turning points, relative minimums, relative maximums, what a polynomial function is, and then of course all of our end behaviors, which I think I already gave you a little cheat sheet for, okay? All right, that's it. You have an assignment in Google Classroom, and I hope you have a very Merry Christmas and a Happy New Year, and I will see you next year. And I like a cartoon right here. Here's infinity running away, and X is chasing after him and says, as X approaches infinity, just don't let him go off on a tangent. He goes on forever. Oh, that's hilarious. Okay. All right, you guys, have a good one. Talk to you later. Bye-bye.